the meeting supporters, in particular ICANN, for providing all of our facilities and catering free of charge. So thank you, ICANN, again. I'd also thank you to Salesforce for contributing to the social costs last night. There's still plenty of room for lightning talks, so we're still going to try and close submissions for these at 11 a.m. before the start of the break this morning. So please, if you have stuff you want to talk about, something you want to throw together or recycle or rant about, we'd like to hear your submissions. Jerry is continuing with the demos when he's finished his breakfast. Please go spend some time and see the cool stuff that Jerry is showing on his giant monitors at the back there. I'm not going to bug you to do the surveys because we seem to have a slight glitch with the surveys at the moment, so we'll get back to you on that. A reminder, we're webcasting. If you have questions to ask, then please queue at the microphone in the middle and give your name and affiliation. In the unlikely event of any outages, then if we lose connectivity, we're going to proceed as best as possible without on an offline basis. If we lose power, we'll just wait until the power comes back. Matt Pouncett will be running the PGP signing session at lunchtime. We'll probably do that in here, so if you're not doing the PGP signing session, then please have your lunch outside. If you're participating in that, please get your key information to pgpsign@dnsoarc.net as soon as you can, please. And that's it, basically. I will now hand you over to the Program Committee Session Chair for the morning, Juan.
Thank you, Keith. So good morning, folks, and welcome to the OARC Day 2 morning session. I'm Juan Huck, and I'll be introducing the speakers for this session. And the theme is DNSSEC key rollovers. And our first speaker is Matt Larson from ICANN. So welcome, Matt.
Thanks, Juan. Good morning, everybody. I'm here to give you the latest update about the root KSK rollover. I'm as excited to keep giving these talks as you are to keep hearing me give them, but away we go. So I want to start with a brief recap of how we got to today. I know if you've been following, you probably know this, so I'm gonna go fast, but I just want to make sure we all know the developments to date. So VeriSign analyzed RFC8145 trust anchor data that had been sent to A&J root. This was like last August, September, and there were a very small number of resolvers reporting at that point because the RFC is so new, the implementation changes are so new. So under 1,500 unique IP addresses per day, but a significant percentage were reporting only the old key, KSK 2010, about 7 to 8%, and this was, well, we honestly didn't know what to expect because we didn't have any hard data, but it seemed like a number that was high enough to raise eyebrows. So ICANN's office, the CTO, had access to 4 letters worth of root server data. We looked at the entire month of September. We found about 12,000 unique IPs reporting total, only about 500 of them when we whittled it down reporting KSK 2010. A slightly lower percentage, but as you see, the percentages jump all over when you look at this data. And we made the call, as everybody knows, to postpone the KSK roll to figure out what was happening, to try to understand this a little better. So we made an attempt to try to contact those 500 resolvers. We thought, all right, we know we got 500 IP addresses who say they only have KSK 2010, why? And we found out, no surprise, that's really, really hard. It's just hard to go from just an IP address and find a human, let alone a human who wants to talk to you. So, so only about 20% of these addresses could be contacted, and of those, 60% were in regions of IP addresses that were pretty obviously used for dynamic things, either home broadband or VMs or containers, things like that. And about 25% were actually forwarding queries from other resolvers. So that's an issue with the 8145 protocol and signaling in general, is that you can't tell if the report is from the actual origin sending you the report or if it's been forwarded, if they're forwarding it on behalf of another resolver that queried them. So The upshot is there was no smoking gun single cause. It would have been wonderful if we would have been able to find that the majority of the resolvers had a particular single cause, and then we could adjust our messaging, talk to vendors, whatever. But that was not the case, and so that left us with no obvious path forward. So ICANN, being a bottom-up, multi-stakeholder, policy-driven organization, we decided let's go to the ICANN community and get the community's input. So we opened up a discussion on the KSK-rollover at ICANN.org list, which you should all please be on. Super low volume, not onerous. And the results of that discussion were as follows: that there was no way to really accurately measure the number of users that would be affected by rolling the root KSK. So all along, going way back to the design team, the criteria that we've been using are users affected. And it's really hard to get from resolvers to users. Is a resolver supporting 0 users, 1 user, 100,000? There's just no way to know. There was hope among the contributors that there'd be better data for future KSK rollovers, but this was a group of people, at least the ones who commented, who thought, let's just get this over with, let's roll the root KSK, but I can keep talking to everyone to get the word out. So that brings us to today and the results of moving forward from there. So we published a draft plan on February 1st, and I want to emphasize the draft part of this. It's a draft plan that calls for proceeding with the root KSK rollover exactly 1 year delayed on October 11th, 2018. We had asked as part of that discussion, is there anything we should be measuring between now and then, and nobody had specific suggestions for that. We're going to continue the outreach which we've been doing, which means that you're going to keep seeing, what did I do? You're going to keep seeing me and my colleagues. And then we're also going to publish the results of the trust anchor observations that we have, and that's actually the bulk of my presentation here, is to talk about the RC 8145 data that we've been seeing. So I really want to emphasize that this is important. There is a public comment period open right now, an official ICANN public comment period on the draft plan. There's the URL that closes April 2nd. So we really, really want to hear from the community about this. Here is our draft timetable for how this will proceed. We are at line number 2. We are holding sessions at ICANN 61 for community feedback. When the comment period ends, based on the feedback, we'll revise the plan. By mid-April, we'll publish the standard staff report that's required at the end of a public comment. The ICANN board meets 6 times a year at ICANN meetings, and then what are called board workshops in between each meeting. So the next board workshop between meetings is in mid-May, and so at that point, we're going to request that the board request SAC take a look at this, and that SAC officially weigh in. Then at ICANN 62, you'll see me or someone else again holding another session for community feedback. We're hoping that SAC can get back to us by the 1st of August, and then the idea would be mid-August we publish a plan, and that plan for the roll, if it happens, if the result of the final plan is indeed a roll on October 11th, that would be contingent on a board resolution, which would happen at a board workshop in mid-September. But again, I want to emphasize that this is all draft. We really, really want to hear from everybody. If you think this is a good idea, let us know. If you think it's a terrible idea, let us know. The public comment period has been open for how long? 6 weeks? 5 weeks? We have 2 comments. We need comments, please. All right. Let me talk about the data that we are seeing. At this point, the ICANN Office CTO has access to RFC 8145 data from 11 root servers. I will let you look at that list of 11 and figure out which ones are not there, G and H. And so we're very, very grateful to the root servers for contributing this data. The initial analysis of this back in the fall used PCAP data. Now we are using an excellent DNS plugin, DNS CAP plugin that Dwayne wrote. That's called RZ Key Change. Long story short, it very cleverly uses DNS itself to report results. So DNS CAP is sees the traffic from these various root servers. Every 60 seconds, it batches up various statistics, including which source IPs it's seen trust anchor reports from and which trust anchors they've reported, and then it sends them encoded in queue names to a particular zone. We have query logging turned on, and presto, we have all this data. So there's an example of the kind of queue names that get sent for what it's worth. Timestamp IP with dashes instead of dots, then the actual trust anchor in hex, so 4A5C is KSK 2010, 4F66 is KSK 2017, and then we know which particular instance, and we know which particular server. So when you take all that data, here's the graph of all of it. So this graph is, I admit, a little hard at first maybe to wrap your head around, because I'm showing two things on here. I'm showing number of sources, so number of source IPs reporting, and I'm also showing percentage. So the red and the green are numbers of sources, use the y-axis on the left, and then the percentage is the black line, use the y-axis on the right. So if we look at this, this is one of those up and to the right charts. You can see that we are getting more and more people reporting RFC 8145 data. So there's really a lot of deployment of this, to the point of about 50,000, just over 50,000 unique IPs reporting per day. So each of these data points is per day, per 24 hours. However, look at the black line, look at the percentage. Now we're at about 20% reporting only KSK 2010. That's moving in the wrong direction. So you may notice, of course, the elephant in the room is that big spike in mid-January. Well, what's that? Well, we have a hypothesis that it is probably Unbound 168 being released. This fixed a vulnerability, so it was a security-related patch, and the hypothesis is that people had a motivation to upgrade. 8145 has been enabled by default in Unbound for a couple of releases now. And so that's why we think that is. But then why is there no drop-off in KSK 2010? Why, after 30 days, RFC 5011 should kick in, and we should see that go down. And we haven't seen that. So our further hypothesis is that a lot of these are simply dynamic or ephemeral instances of containers or VMs that come up with KSK 2010, and they're never alive long enough to complete the 5011 process. And they have an old configuration that only has KSK 2010. And they don't run, if it's Unbound, they don't run the Unbound Anchor program to bootstrap and get both KSKs. Here's for all 13 root servers, or I beg your pardon, all 11, A at the upper left, M at the lower right. I show this just to show, and this is available on the website in the URL I'll give in a moment, so you can see these in larger format. I show this to show that for the most part, they're all the same pattern at all the root servers. E, this is the middle, exact middle is E, lower left there with no data is I. They've more recently started sending data. J is the one in the third line in the middle. It has a lower percentage than everybody else. And Dwayne thought maybe that's because we're not getting reports from all of J's instances. I don't know, that's something to look into. Now this is interesting. So here's the same time scale on the bottom. This is unique IPs added per day. So we start back in September 1st. We have a set of IPs that reported on September 1st. And now bear in mind that we've been adding root servers to this data as we go along. So then the next day we look at all the IPs that we see on day 2 that we didn't see on day 1, and that's a unique number. Then on day 3 we look at how many did we see new on day 3 that we didn't see on 1 and 2, and so forth. So you can see at this point we're adding 15,000-ish new IPs per day. Never seen before. They report in with 8145 data. This is cumulative IPs, cumulative unique IPs over time. So it would be basically taking this graph and adding each data point to form these lines. Actually, so this graph, the green, is really a combination of green and red because it's all reports total, whereas this green is those with KSK 2010 and red is those with, or I beg your pardon, Green is good, green is KSK 2010 and 2017, and red is only KSK 2010. Black is still percentage. Look at that, now it's 35% when you look at it from this perspective. The other thing is, if you do, no, you know what, I'm sorry, I misspoke. Green is the same. Green is the same on both of these because it represents all the addresses. But notice where that green line drops off. As of today, we've seen, let me skip quickly ahead. We've seen 732,000 unique IPs since September 1st, reporting 8145 data. And that's the breakdown of old versus new. And these, if you do the math on 267,000 versus 464,000, you get the 35-ish% there that's being shown. So I did the analysis with cumulative /24s. There are a lot of /24s as well. If you look at the scale on the left, there are only about half as many. So the average would be about 2 IPs per /24, a lot of /24s. Another thing to look at is the total number of IPs reporting versus those that, well, let me say it this way. We see a few IPs that report both KSK 2010 and they report at some other point KSK 2010 and 2017. So they appear in both lists. But that number is only about 1,550. So those would represent, in a perfect world, like people who had upgraded, right? Maybe they reported KSK 2010, they changed their configuration, then they report KSK 2010 and 2017. So looking at the data this way, there are not a lot of people upgrading. This is the URL to look at the graphs that I've been showing. We'll probably add graphs to these. Not every graph I've shown you today is in there, but the first one is. Here is sort of late breaking data. I haven't had a chance to do a whole lot more than this other than make this chart, but these are the top ASNs reporting. So you can see, and this is based on, this is a couple of weeks ago, so this is not that complete 730,000. But this gives us something to do. We can see that there are some ASNs that stick out here with a lot of reports. I mean, really 41,000 out of, what's that, 5%? So that's a significant number. That would be some low-hanging fruit to follow up. We're letting the community help us with this. The ISPCP and some of the RIRs have expressed willingness to help track down operators to both get those systems upgraded and then find out why is it we have this situation. We're considering making this list of IPs more widely available. I just don't know if that's going to happen with GDPR and everything else. Yeah. If I say blockchain, then I'll have hit both GDPR and I missed IoT. Yeah, sorry. All right, so next steps. We are going to keep investigating 8145 data. We're going to find out, for example, why both E and J have that lower percentage. We're going to look into source autonomous systems. As I said, we can easily contact some of these ASNs, ask what's going on. We can encourage and assist other people who are doing this analysis. We're going to keep talking about this, and we're going to keep listening to you. So what you can do is, once again, let me make a plug to make a public comment. And it really would be good if everybody joins the KSK-rollover at ICANN.org list to hear about developments in the project. And so with that, I'm happy to take any questions. Well, shout your question, and I will repeat it for the online folks.
So the one question I had based on your data is you said that you had a whole bunch of IPs that were in dynamic ranges, but yet you were counting unique IPs over time. Did you ever go back and see, well, some of those So you try and account for the fact that some addresses may have been a very temporary time window in this graph.
We haven't done that yet. That's an obvious thing to do, and we just ran out of time in the analysis. Thank you for that suggestion.
What was the question?
Oh, sorry. The question was, have we looked at when IP addresses occur? Do we see some that maybe only occur on a particular day and we never see them again? So they really are truly indicative of something being ephemeral.
You ask for help, but don't publish the data. How can we help to contact the people?
Well, that's a really good question. We can, we're working through the RARs and the ISPCP. So that would be my suggestion. At this point, the list of IPs is effectively public, having distributed it. I'm hoping that we can make it more widely available, but I'm not a lawyer, and so I can't say that just yet.
So don't ask for help.
Okay.
Question about irregularities. On slide number 4, if you could show the bullet points.
I'm sorry. Which slide, please?
Number 4. The first one. What are we trying to measure here? What is the measure of success? Is it that the users can successfully continue working, or is it that we clean up the server population so that every server is moved on to the new KSK, which are different things?
Absolutely.
And also different roles for ICANN. One is kind of a public service ensuring role, and the other one is some sort of internet police. So I'm trying to understand what the objective, what would be a successful.
Well, so ultimately, it's the users that matter. That's what we've said. So it's the number of users affected. We want to minimize users. But of course, we don't have a signal yet that talks about users, that can directly measure user activity. Okay. So what we do have is this data that, frankly, I almost wish we didn't have, but we have it. And it's the only thing we have. It's quantitative data. So I feel like we have to. We would be remiss if we didn't analyze this data. So
sure.
You know, that's.
But I'm just looking about what's the desired outcome, basically.
A desired outcome is users do not lose access to the internet.
Right.
It's all about the users.
Okay. One other thing, in your measurements, is there a way you might be able to distinguish resolvers that are not rolling versus instances of smarter stub resolver code, like, I don't know, smarter APIs that are being deployed somehow?
If you know what that signal might be, you'd love to hear it.
Okay.
So, folks at the mic, if you could say your name, that would be helpful. That was Joao Damas, by the way.
Hi, I'm Robert Martin-Lejeune from PCH. Back many years ago, I used to run a sendmail thing that wouldn't accept email from dynamic dial-up thing addresses by doing a DNS lookup in a blacklist. Have you considered correlating the IP addresses and the uniqueness of them with something like that?
Not that specifically, but that's a good idea. Yeah, if anybody knows if there's a list somewhere that says this is a dynamic IP, that would be wonderful to have. Wonderful
Warren
to know.
knows. He nods.
Okay.
Right.
Jeff Houston, APNIC. You've got two problems. So let me look at the first one. You're trying to chase down, if you will, bad apples when your real problem is folk eating toxic oranges. You know, it's kind of users, you're looking at resolvers.
Absolutely.
You've got a problem because you don't know which of those resolvers are actually DNSSEC validating, do you? And only the ones that do validation get caught. Now, I happen to have a list, and I'm sure there are others who have compiled the lists of resolvers that validate, which you actually need to cross-correlate before you start looking at that.
Which we've done a little of with you.
A little. And the next problem is, of course, there are estimates of users behind resolvers. You know, and
I know, and we've done a little of that
clever.
too. Yeah.
But the second observation is the one that really is salient here. Around 30 to 35% of the world's users send their queries to DNSSEC validating resolvers. Less than half actually stick with a result that is serve fail, invalid. The other half go to a different resolver and go, oh shit, you didn't give me an answer, I'm desperate for an answer, anyone who's not validating, give me an answer. The folk who are going to get lost on the key role are the folk who have no non-DNSSEC validating resolver in their etc.resolve.conf. So this is a lot of effort, but it kind of amplifies a non-problem. And so I commend to you as much as possible this Sentinel stuff, which tries to measure what the user will experience. And when the user gets serve file from one resolver, checks all the others, is actually far more valuable than hunting down this. Because this is a whole lot of work that I think is misleading us all, right? If we took raw resolver numbers for DNSSEC validation, we'd be sitting there going, half the world validates. That's not true. And so this whole issue that it's not the resolvers that are really the problem we're trying to hunt down, it's the behavior of users as they move across all of the resolvers in etc.resolve.conf, and you're trying to find the ones that only have KSK 210 and validate every time, are in the pool of you're about to die.
Yeah, no,
And that's what we need to identify.
I agree. What's the saying? You go to war with the army you have, not the army you want. Well, so this is the data we have, not the data we want.
I'm trying desperately hard with Warren to put forward a draft through the interminable processes of the IETF to try and give you something that looks more like a life raft than a straw.
So looking at the data that we've got, do you still have enough time series in that data to be able to look at whether IP address sources are bouncing back and forth? You noted that some IP addresses show up in both lists, but do you know, for example, that today it was in only 2010, tomorrow it was in both lists, and the day after that it's back in?
We have every report. It's effectively this. So we have a timestamp on every report, and we have all of them.
Yeah. So that might be another indication of forwarders or other ephemeral, resolvers. And that's what I mean by other ephemeral resolvers, is things like Docker and stuff, which was a suggestion I was going to make. Is one thing to be looking at in terms of potential sources of these problems is to go to places like Docker Hub and other distributors of containers and find DNS servers that people are downloading and find out whether they are pre-configured with the wrong key sets.
Mm-hmm. And tell us your name, Matt.
I'm sorry, Matt Poundset.
Peter Koch-Dienig. First, I think it's scary that we, by further going down the road, no pun, find more things that we don't know, but that makes the thing challenging and interesting. My question is, and maybe I've missed that, so in that case I apologize in advance, did you notice any difference between V6 and V4?
We haven't specifically looked at them, at least for this, we've not looked separately for this analysis, but we have all the data. Roy, have you, off the top of your head, you've looked at this a little bit too? I'm sorry, I'm putting you on the spot.
No worries. We haven't looked at the difference between IPv4 and IPv6. We took every IPv4 as an individual report, every IPv6 as an individual report. In counting these unique addresses, we made no distinction between V4 and V6. So, yes, we can do that, but like Matt said before, we kind of ran out of time.
Okay. But the churn might be higher in V6 for a variety of reasons and so on and so forth. Yeah, thank you.
Yeah, that's another good idea. Thanks.
Hi, Dwayne Wessels from VeriSign. I have a question about the slide you had with the AS numbers, the table of the, So this is all reports, is that correct?
Yes.
Okay. So would you be willing to, make a table like this of just the KSK 2010 reports?
Oh, absolutely. Sure.
Maybe put that on that webpage.
Yeah, and this is Team Kumari data is the source of this.
Yeah. Okay.
So
cool. Thanks.
Yep, that's a good idea. Happy to do that. All right. Thank you.
Okay, so our next speaker is Warren Kumari from Google, who will be talking about KSK Sentinel.
Let's see if I can, okay, full screen, woohoo. Good enough. Nah, it's good enough. So, KSK Sentinel. Oh, wow, I keep forgetting that I'm not tall. Seriously? So, so this is going to be sort of a follow-on from Matt's talk. I'm Warren Kumari. There's Jeff and Joao. This is joint work. I'm just the monkey here talking. So, what's the problem? Matt covered a lot of this, but we'll flip through it quickly just because we have the slides. So we really want to roll the KSK. Some would say we need to, some would just say we want to. Whatever the case, we'd like to have a new KSK. Users who are using validating resolvers that don't have the new KSK break. Right? This means their users who are using these have no working internet for all intents and purposes. Without the DNS, the internet is kind of useless. So in case it wasn't clear from all the questions and comments before, we have no way of measuring deployment in a way that gets us good, useful data. And so we don't really know who's going to break and also how many people will break. So yeah, RFC 8145. I was one of the authors. Paul and Dwayne are also in the room. We generated this data, and we think it's useful. Right? It exposed that there was some stuff that we didn't know things about. We thought there was actually going to tell us, what the real impact of this, as you saw from the previous presentation. Probably no, it doesn't actually tell us what we thought it would tell us. What this does is it provides reporting from resolvers. It lets us know what resolvers have the new key, what resolvers only have the old key. At this point, after seeing Matt's presentation, I'm not even sure that we can really tell that. That huge spike of 30% or jump to 30% makes me wonder if maybe there's something more fundamentally broken in resolvers' sort of reporting of this. But whatever the case, this provides reporting from resolvers. Me, I have a validating resolver in my basement. It doesn't have the new key. It actually happens to be a Docker instance, and I reboot it sort of every day. And so it starts getting the new key, but it never waits 30 days, and so it doesn't have the new key. However, nobody's actually using it. So, if a resolver falls in the forest and nobody's sending it any queries, does that actually matter? And I actually feel really bad for ICANN/the ANA because they've got this sort of set of data. It looks kind of like this. This is a old graph. What it shows is there is some set of users or some set of resolvers that do not have the new key. But, it's really hard to know why. It's really hard to know if these are actually going to cause an impact. However, ICANN has this data, and I think it would have been irresponsible of them to just completely ignore it. So I think, they did the right thing by stopping and having a look and trying to figure out more. I wish the data told us more. It does make pretty graphs. That's always a good thing. But what we'd actually like to know is how many users are going to be affected when the key rolls. So we're proposing this new thing called KSK Sentinel. It requires what we think is a very simple resolver update. And more importantly, it allows anybody to set up a measurement service. The current RFC 8145 stuff, what that does is resolvers report to the trust anchor, or the trust anchor operator, sort of the distribution of resolvers. This will allow anybody who has the ability to publish DNS records to set up some sort of measurement service. More importantly, it exposes the results of the sort of test to the users. As I said, RFC 8145 exposes the results of validators to the trust anchor operator. This allows actual users to test their DNS and understand if they're going to be affected or not. It also, of course, allows DNS operators or resolver operators to test and understand this. So the change is, as we say, fairly simple. When a validating resolver goes off and does all of its work, it does the resolution step, it does all the validation step, as the very last step before it sends back the response, it has a look and a check to see if the leftmost label in the query starts with KSK role-sentinel-is-TA and then a key ID dot, something. As I say, this is just the leftmost label. If it does have a key in the trust anchor store for the root, and it has that particular key tag, then it just moves on with life. It sends back the answer like it normally would. If it does not have a trust anchor, or if it does not have a key, with that key tag in the trust anchor store, it sends back a serve fail instead. Basically, it pretends when it was doing the resolution, something bad happened, or when it was doing validation, it wasn't able to validate. Basically, serve fail is a generic, something went wrong, I don't know what. So yep, we're overloading an error code, but well, it's not the first time anybody's done that. The second rule is basically the inverse of the first. If the leftmost label starts with key role -sentinel -not TA and then the key tag, then if I do not have this key, reply normally. Otherwise, I convert it into a serve fail. So this is all a little confusing. We'll quickly go through an example. Me, I'm a validating resolver. I don't look like a validating resolver, but really I am one. I support the Sentinel mechanism, and I have the new KSK. This is our sort of scenario. First off, I get a query for invalid.example.com. I am a validating resolver. This name happens to fail DNSSEC validation because it has a bad signature or something. So I do what I normally do. I send back serve fail. A little while later, I happen to get a query for KSK role sentinel is TA20326.example.com. As I say, I support the Sentinel stuff, and I have the new KSK. I've gone off, I've done all of my resolution. It happens to resolve to 192.02.23. Because I have the new key ID, I just send the answer like I normally would. I reply with what I got out of the resolution stuff. A little while later, I get a query for KSK role sentinel not TA 20326. However, I do have this key ID, and I support Sentinel, so I follow the rules. I do not have that key, and so I send serve fail. The whole I do not have that is a little confusing. For Simpsons fans, it's kind of like the Homer, I'm not licking toads, right? Swap your answer backwards. Okay, so we've just added a whole bunch of complexity and stuff to the DNS. People keep doing that. Why is this one interesting? Well, what we do is after we've done this, we ask users to go and browse to a web page. And on the web page, we have a couple of images and links. I think that people can most likely read it, but basically invalid.example.com/fish, KSK role sentinel is TA, example.com/kitten, KSK role sentinel not TA, blah, 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 .puppy. And we ask users, when you go to this web page, do you see a fish? If you see a fish, then it means you are able to get the invalid.example.com/fish picture. This means that you're not behind a validating resolver. This KSK role thing is completely irrelevant to you. You're not validating, so meh, you will be fine. If you see a picture of both a kitten and a puppy, this means that you're behind a legacy resolver, a DNSSEC validating legacy resolver, because you are able to both get the kitten picture and the puppy picture. That means you are able to resolve both the is TA 20326 and the not TA 20326 names. Because you can't both have the key and not have the key at the same time, that means you don't support Sentinel, and so we unfortunately can't tell you if you will survive the key roll or not. If you only see a picture of a kitten, then this means you've got the new key. It means you were able to get the is TA 20326 name, and you were not able to get the not TA 20326 name. This means that you got the new key, you will be perfectly fine, you don't have to worry about this, life will be good. If, on the other hand, you only see a picture of a puppy, this means that you've only got the old key. You do not have the is TA 20326, and you do not have it. So, that means that when the key roll happens, you will break. So, seriously, we're going to have users go off and look at pictures of things and tell us if they see kittens and fish and puppies and stuff. I wish that were the plan, because it would be really entertaining. Sadly, no. Instead, likely, in fact, this is currently from a thing I have running, there will be a big blob of JavaScript. And we will, 10 minutes, cool. We will force users or encourage users to go off and fetch these resources. This is basically the last set of examples that I showed, the whole thing with the puppies and fish and things, but all automated with JavaScript. And so, we won't actually expect users to look for pictures and tell us what they see. But yeah, I know, but kittens. Sorry, still no. We've actually got a very much proof of concept / demo site set up, which does basically these tests. This is what you will likely see if you do it right now, because you're currently behind, at least if you're using the ICANN resolvers, you're behind a legacy resolver which does validating. But nope, even this, we're not really likely to ask users to please go off and browse to this web page and figure out what's going to happen and call their ISP if it doesn't work. Most likely what will happen is somebody like Jeff or similar will run one of those large-scale internet measurement things where they serve people ads, and that will make users go off, large-scale groups of users go off and do the test and report back. And then hopefully somebody like Jeff will give the answer to ICANN, who will then publish it, or maybe Jeff will publish it himself, or who knows. But basically, the big important thing here is instead of 8145, which generates a lot of data and makes pretty graphs and tells you sort of what resolvers will experience, this should actually tell you what users will experience. And I think that that's fundamentally a much more useful and important metric. So questions, and yes, before everybody starts throwing tomatoes, I realize I went through and I spoke about kittens and stuff like that, and you did not actually get any pictures of kittens. So here is the gratuitous pictures of kittens. For some reason, they're gardening. I don't quite know why, but hey, kittens. Yeah, I don't really like puppies and fish, so cats are obviously, oh, I shouldn't be saying that on stage, should I? Oh dear.
I just wanted to point out one area where we have to be careful of terminology. Oh, David Lawrence, based on something Jeff had just brought up on the previous presentation, which is if somebody's fetching invalid, you don't know that the key role is not going to affect them. You only know that they were able to fetch the invalid, because they might be falling over from somebody who is serve failing on it, and all their lookup times are now being increased by every time they hit.
So yeah, so this is, and probably there needs to be more discussion of it. This is both a feature and a bug. What we're trying to measure here is if users will actually break. And so what we're trying to figure out is, do users have a path to a correctly working validating resolver, or a correctly working resolver system? So if you've got 12 resolvers and the first 11 of them all only have the old key, you will try this and you'll get so fail, so fail, so fail, so fail, so fail, so fail. Eventually you get a working response. Yes, your resolver time might be way longer, but you fundamentally do still have a way to reach the internet, and so you can, we think, be counted in amongst the set of people who will survive. You might not be happy, but you will survive. Dwayne, sir.
Hi, Dwayne Wessels from VeriSign. So I think it's obviously great, to measure users instead of resolvers.
Or both.
Or both. But something you said early makes me want to get up here and I guess defend the honor of 8145. You said, for example, that you have a thing in your basement that's, I guess you implied that it's sending out signals, but it's not getting any queries. And a careful read of 8145 would show you that, the signals are only supposed to be sent if you're actually doing validation, if you're actually, requesting the keys. That was the language in the RFC that we used, that you should send the signal at the same time that you're doing a DNS key query, right? And so if you do have a resolver that's not actually getting any traffic, then it should not be sending any signals.
Well,
that it didn't get implemented that way, but the RFC said that that's how it should work.
So I mean, yes and no. It's a instance of bind running inside a Docker container, and it starts up and it runs for 24 hours, at which time cron kicks it in the head. And so it will actually go along, and even though it's not getting queries from users, it will still, after 6 hours, try and do the 5011 rollover start. Okay. So I think it will signal. But I mean, yes, it's a pathological case.
What I'm saying is that when we wrote 8145, I think we were naive
Yeah.
in our assumptions that it would get implemented the way we thought it would get implemented, and it didn't get implemented that way. And so for this, I would, I guess, encourage you to think very carefully about all the ways that it could get misimplemented, have lots of tests, you know, to make sure that it works the way it works, that it should be work. You know, what does it mean if you see a fish and a kitten? That was not something that's not a case that you covered on your slides, and so that could actually happen, right? Somebody could pop up a web page and see a fish and a kitten, or a fish and a kitten and a puppy. What does that mean, right? So think about those odd cases.
Yeah. Yeah, and I mean, actually, I think 8145 was really useful. I think that it exposed the fact that not everybody has rolled over to the new key. So, I mean, yeah, I think that it was fundamentally a really good thing. It just doesn't provide, or after we've run through the process and seen the data, we realized that there's a bunch more useful stuff that would be important to report as well. So this was not a
I guess my point is that even I was naive about 8145, thinking, oh, this is easy. We'll get some good data out of this. But as we know, every time we look at DNS data, you see stuff that just makes no sense.
Oh,
and I think you're going to see that with this also. You're going to see stuff that's like, you know, fish, kitten, puppy. I didn't expect that. What does it mean?
Yeah. So actually, fish, kitten, puppy, just for that particular one, I mean, I realize that this isn't actually speaking to your point, but just, you know, I should have covered it. If you're behind a non-validating resolver, you will actually all see all three. I guess I should have updated that, because you can get invalid and the others. But yeah, let's go back to the picture of kittens, because kittens. Yeah, it is.
Joe Abley. So this is all very clever and good, and I think it's great. But I think the bigger question, maybe this is a question for Matt, but the queue was already really long for Matt, so I didn't join it. At what point do you stop measuring things, and at what point do you say the only real way to clean up the remaining breakages is to let them fail? Because that's the only real impetus that some things will ever be fixed, and some things won't be fixed, and perhaps we don't have to care about that. I think we're already in a situation where I think we have enough data to know that the number of impacted users is already pretty small, because we know, for example, Google Public DNS is not a problem, and that accounts for a vast chunk of the world's validating users. We already know that the proportion we even vaguely care about is small. The data we're looking at is a fraction of that. I mean, I think unless we have an idea of how much breakage is acceptable, we're never going to roll the key. And I think the problem is that ICANN's in a situation where the only real decision ICANN can make is not to roll the key. And I don't think they're in a situation where they can say, this amount of breakage is okay, because things break every day and people will fix it.
The community needs to tell us.
Yeah.
Comment period. Please comment.
Yeah.
And we do have a date, October.
Okay.
Yeah.
I mean, I see we're engineers making engineering decisions and assuming that we can make the world a perfect place, but the DNS is awful.
So yeah,
DNS is really, really bad and nasty.
Jeff and I have had some basically shouting matches about this. I think that it's our job to try and provide the data. I think that it's the ICANN board's decision on how much risk to accept, you know, or the ICANN board with input from the community. And as people keep saying, you know, that is public comment period, please comment. I think that having them have the data is probably good. But yeah, it's a policy decision on how much risk is okay, and I'm not choosing a number.
I mean, we have one apparent data point, which is we didn't have the 8145 data, we'd already have rolled the key. So maybe more data is not good.
I wasn't listening, Joe.
Robert Edmonds, Fastly. Given how long it takes to deploy new resolver code across the internet, is this mechanism targeted at the next key rollover, or is it the intention to produce usable data for the current?
So if this were to be published and one or two people were to implement it, and then there were to be some very large DNS vulnerabilities published, everybody would upgrade. So I encourage people to go off and look for vulnerabilities. So yeah, I mean, I don't know. Ideally, we would have done this, you know, a year ago, in which case we would have useful data. Oh no, Paul is walking up. Maybe he's going to talk about some new vulnerabilities. I should have kept quiet. But yeah, I don't know. You know, I think it would be useful as soon as people start reporting, we can see some set of data. Maybe the data will all be perfectly clean that we do see, and then that won't be a question.
Ralph Weber, Akamai. So one question, probably more, or a hint to Jeff, is what David said. the cases where sort of the people go to the next non-validating resolver and then sort of get something is a case where probably a lot of carriers will get then support calls. So it would be good if you could, in your measurement, sort of see how prevalent this case is actually.
Very quickly to answer that, this is Jeff. What we do right now is a mass scale measurement between 5 and 10 million samples a day. And one of them is indeed a deliberately invalid DNSSEC signed DNS name, right? So what we see with those, in all those cases, is the ones that validate and then flip over to another resolver that then doesn't ask us the same set of questions. In other words, all they're doing is resolving the name without doing the RRC queries, et cetera, they're not validating. Users are fine with this because they've sort of asked the DNS a question and it's just throbbing through. If one return serve failed and their local timeouts, they just go and ask another resolver and et cetera, resolve.conf. They're searching for an answer. And most of the time, they get the answer one way or another. The few that only use DNSSEC validating resolvers eventually give up going, I can't go there.
Yeah, but the users will get the answers much, much slower. And when they get the answers slower, because the first term did not answer them. In the case where we roll the KSK, right?
So the way, again, the experiment works, we have a 10-second timeout.
Yeah.
So the ad is continuously running while you're watching kittens on YouTube. Go for it. We say within 10 seconds, did you go and fetch that web object or not? After 10 seconds, we've kind of agreed. You've got bored, I've got bored, kittens are no longer in favour, we're on to something else.
So actually, I should also clarify, I think 2 people have said this. I don't think that it's actually you need to wait for the timeout, right? What happens is you get back a signal from your resolver saying serve fail, and you immediately kick over. So it doesn't add a full timeout, which is 2 seconds or so. It adds an extra 20 milliseconds or...
Right, but a lot of resolvers, especially the ones that validate, try very hard to validate.
Yeah.
So.
Yeah, but yeah, yes, that is the thing, yeah. And so, this might actually also kind of be a feature. If your resolver gets slow, you might eventually stop using, that resolver and you'll move on to a better one. But it's probably better than having everything broken and then you can't even open the Google and type in, how do I fix my computer?
This is Andre Suri from ISC. With my Debian hat on, mainly to answer Robert's question. If the vendors that implement this feature into the DNS server provide us small enough patches, I think this is perfectly acceptable for the release teams to accept into the stable updates. And I think that we can talk with the Debian release team that this feature needs to go in sooner than later. So I think we can get this to the users if the patches to implement this feature are like self-contained and small enough.
Okay, cool. So I believe that Not is already mostly doing it. I'm hoping that means Bind will be supporting it real soon. Okay, worth a try. Can't blame a guy for trying.
Paul Lotus, Red Hat. So I've said this a number of times and I'll say it again. If you want us to support newer software or a feature, you must file a bug. I am stuck between all of you, every IETF and every ICANN, and all of Red Hat, which says, we want stable, we don't want changes unless there's a customer demand for it. So please file a bug. Like, get together, buy a beer, open a laptop, and file a bug. Because otherwise, you're not going to see this in 9 months. It is really easy. Like, if there's a bug and there's like 3 paying customers, it's $50 for a license.
This is Red Hat's monetization scheme.
I'm telling you how to game the system. Do it.
Anyone else? Great. Thank you.
Okay, so we're running a little ahead of schedule, but I guess that's okay. Let me take advantage of this opportunity to remind folks that we're still waiting for lightning talk submissions, so please think of an interesting topic and submit it. Okay, so our next speaker is Martin Hoffman from OpenNet Labs. Go ahead.
Thank you. Good morning, everyone. You probably haven't heard of OpenNet Labs, but we are the commercial arm of an ASN Labs, of which you may have heard. And in that function, back when as Matt said, the first 8145 numbers came in and there was no smoking gun. VeriSign was hoping to find one, and they came to us and asked us to look at the various resolvers and how they implement RFC 5011, if maybe there is something. So that's what they asked us to do, and they kindly allowed us to present the findings here today. What we were doing was we were looking at the 3 most popular open source resolvers and how they developed, or how their RFC 5011 implementation developed over time. Now, if you want to test RFC 5011, that's a bit tricky because, of course, the whole process takes very long. The time from when the new key appears first in the DNS key record until the old one is gone is 9 months. If you want to add a little before and after, so you're quickly at a year, and that's of course not very convenient for testing, especially if you have lots of versions. Luckily, there is a way around this. There's some cheating, which the good folks at ZZNIC provide a tool for. It's called Deckard. It's based on some work that Unbound did for testing. It was called TestBound, and ZZNIC took that and made it possible to use it with any resolver. Basically what it does is it wraps around the resolver, it emulates the upstream authoritative servers that the resolver will talk to, and it also emulates the downstream clients, which will go then will ask questions and checks what the resolver comes back with. And very importantly, what it does is it allows you to fast forward in time with a library called libfaketime, so you can do time jumps. And with that in mind, we made our own little domain name system. This is the whole of it. So there is, in all of 7 zones, there's the root zone, of course. There's one signed, one unsigned TLD, and in each TLD, there's one signed and one unsigned zone. For the TLDs and the second level domains, the signed zones, we just didn't do any key role. They just had both keys and signatures for the whole period that we were testing. For the root zone, we did the typical ICANN thing. So we rolled the ZSK every quarter, and we provided the KSK according to the scheme that we were testing. And then with that, a whole thing we did, you see in the actual zones at the bottom, you see the test records. So we did tests for these records regularly with the do bit set and with the CD bit set. And then we were expecting the resolver to either come back with the answer or to come back with a serve fail if we expected the resolver to not have the trust anchor anymore. With that in mind, we built lots of scenarios, specifically these, I think it's 17. Let me quickly go through them. Happy Path is the original ICANN schedule. That's, of course, now already obsolete. Unpublished before signing is rollback and remove the old key, the new key before you even start signing with it. So you just drop it from the DNS key record. Rollback after signing is you start signing with the new key, and then go back to the old key. A revocation of old key tests, whether revoking works as expected. Early reintroduction of the old key tests, the remove hold down. So we revoke the old key, wait not long enough, but add it again, then wait for the add time, and then it should still not be accepted. Early reintroduction of old key is similar in that we test whether if you have the revoke time, you leave that and then wait for the add time. But no, don't wait for the add time. So you have it properly revoked, wait for less than 30 days and bring it back and check if it is used, or rather if it's not usable. Unrevoked old key is you wait the whole time. So you wait for the remove time, you wait for the add time, and then bring the old key back, which RFC 5011 is a little unclear if that's okay or not. It says it is okay. So we check what the resolvers do with this. Then, well, reintroduction of old key. That's probably that too. These are all very confusing. Missing new key is there's a state in RFC 5011 where you leave out the new key after the at hold down has passed. You remove it's missing and it comes back and it should still be valid. So we check that. And then there's a bunch of operational things which are quite interesting. So non-rewritable state directory. That's of course the one that probably happens very often, particularly nowadays with all these Docker containers. So we checked what the resolvers do if that happens. Resolver restarts during the test period. We regularly restarted resolvers, see what happens there, combination of both. Then there is a very interesting case where you install less than 30 days before the actual KSK role, or either with only the old key or with both keys. And then just to make sure, we also installed a resolver with only the old key or with only the new key after the reinstallation, or after the role, and checked what happens there. And then there was 2 cases where the resolver was only forwarding to another resolver or to a recursor upstream. One was forwarding to a non-validating resolver, which should be working, and then there was a case where it forwards to a non-DNSSEC resolver, so a resolver that doesn't even understands the do bit, which we discussed and discarded, because at least once you get to NSEC 3, there's really no way to make that work at all. So with that, let's go to the findings. We started with Unbound, just because, well, if something went wrong, we could discuss this and had the people to discuss it with in-house. Let's start with a quick rundown of the history. The first Unbound release was in 2008, first 5011 in 2009, or late 2009 in 140, so in time for the root zone to be signed. The latest release, 168, from early this year. And as a random data point for what's actually deployed, what's likely to be deployed out there, Debian currently carries 160, which is from roughly a year ago. So what were the findings? Everything went fine except for one thing, which is the late installation with, so the installation less than 30 days before the actual key roll, which Unbound wasn't quite happy with. In fact, it would only accept the new trust anchor after the 30 days, even if you installed it with both. That was a bit weird. That was fixed in 165 last year. So this is now okay, but it's only like a year that has been fixed. So this is likely to be a problem if people install old versions before the roll, or not far enough before the roll. With regards to reintroducing the old key, that was the thing where if you wait for the remove and then the add hold downs and then bring the old key back, Unbound will accept the new key. Quick look at the operational perspectives. One is that Unbound needs a different configuration for switching from a fixed trust anchor to a trust anchor that's managed via 5011. But really, because 5011 support was there before the root zone was signed, there's really no reason to have installed a fixed trust anchor with the root zone. Non-writable state directory. Initially, Unbound would log an error and then keep going, which means everything would be fine until the next restart, when your resolver would go bogus after the roll for no particular reason. That was fixed in 2015 already, so now Unbound basically just won't start. When you start it with the state directory not writable, it will just stop and give you an error. Next up, bind 9. We didn't test bind 8 because bind 9 already is from 2000 and wouldn't in fact support the current root anchor at all until 962. RFC 5011 came in 9.7 in 2010, so still in time for the root zone. It worked in 9.7.1 according to our test, so the released version failed. The latest release is 9.12, also from January, and Debian has 9.10.3. What did we find? One point is the reintroduction of the old key, which we also had in Unbound, which is that initially it accepts the old key even before the hold downs had passed, so it would accept it too early. That was fixed in 9.10.2. What it now does, it will not accept the revoke key again. And then there was an interesting thing where if you installed post-roll with the old key, it would actually go insecure instead of bogus. And that was fixed in 9.10.4, about, 2 years ago. Also, the operational things like Unbound by 9 needs a different configuration. The non-writable state directory was similar to Unbound. It would log an error and carry on. But different than Unbound, if you restart after roll, it goes insecure. That's probably related to the late installation thing on the previous slide. That was fixed in 9.8.1. Now it logs an error once and carries on, but goes bogus after the roll if you restart. Oh, actually, yeah. Even if you keep it running, it goes bogus at the restart. So I think it tries to do the RFC 5011 thing once and then finds this doesn't work and it won't continue. And the final candidate we had was not Resolver. It's fairly new, the first version from 2016. It had RFC 5011 since its very first version, though that didn't actually work. We found the first version that worked in 1.2.0. Then 1.2.2 broke again, and then 1.2.5 worked again. The latest release is 2.1.0 from earlier this year, or from not that long ago, actually. And currently Debian has 1.2.0. Now, there was a couple of more findings. First, the common one that we've seen all, the question whether what happens if you bring an old key back. It will do the same thing as Unbound did. It will accept the old key after you removed and add it again. If you install with only the old key less than 30 days before the key roll, things get a bit weird. In 1.2.0, it would accept the new key only during the add hold downtime, and then would not accept it anymore after. And in 1.2.5, it accepts the new key for exactly 1 day. This may have been, we've talked to Zetnik, this may have to do with the way that Deckard works. So we're not entirely sure if that's really an issue with not Resolver or just with our test setup, although it's still a bit weird. And it does the same thing if you revoke the old key, then it would accept the old key for 1 day after the removal and then start revoking it. That, as it says here, that only appeared in 1.5.0, but it's still the case. The good thing about not Resolver is it's always doing 5011 for trust anchors, so there's no operational things. The non-writable state directory, it initially did the right thing. It would stop with permission denied. In 1.5.1, it would also say permission denied, then keep running and go bogus 1 day late. Again, that might be the Deckard thing. And then since 2.0.0, it now stops its start as well. One more thing that we found operationally is that it didn't really deal very well with Resolver restarts. So it would restart, or it would start counting the hold downtime again from the restart, which means it would basically, we restarted it every day, so it would never accept the new key. That was fixed in 2.0.0. Also, apparently that has to do with the not library version that you built not Resolver with, so it may actually also be fixed in an earlier version already. And that would be it. Questions?
Not related, and I have one too few ends. Thank you. This is great. I think the takeaway is everyone should try, all the vendors should try to get their customers to the latest versions.
Yep.
Okay.
Yep. But also, maybe I forgot to say, there's nothing really fundamentally wrong. Right?
Right.
There's little things, but basically this stuff works.
Right. Actually, Ralph and I misunderstood like 2 or 3 slides back where you said Debian had not, right. I said, oh my God, that means current Debian stable has the wrong one. No, it was good, it then went bad, and then went good again.
Yeah.
So it still had a good one, but it was, it's not the latest. Should we be pushing, do you believe that with these results, we should be pushing on Debian and other packaging systems to also be going up to the latest? Or is, or are we, do you feel like we're okay with where we are now?
I think so. Of course, when we say it has this version, the Debian, and so they backport changes. So it may very well be okay to just backport some changes from newer versions. Okay. I think 5011 support in Node is basically just a Lua file. So just taking that might already be good enough.
Okay, great, thanks.
Hello, Robert Edmonds, the Debian project. Could you go back to the unbound slide with the versions?
Yeah. Oh, wait, going the wrong way. Here we go.
So when you say current Debian stable 160, do you mean 160-3 or 160-3 plus deb9u1?
Probably the latter.
Okay.
It is really just a random data point. I didn't really go too much into which backport, which stuff they had backported. I think they backported quite a bit from the newer things.
I just wanted to point out there's nothing wrong with that version because it's not the original 160.
Yeah, absolutely. Yeah, I should have said that. Yeah.
It contains the fixes for
exactly
the new key anchor and the
exactly
fix for the bug.
Yeah, that's correct.
Joe Epley. This all seems really great, and it seems like a really tedious amount of work to do, so congratulations for making it to the end. But I think there's another question that no one it seems to be asking, which is, maybe 5011 is just a really terrible mechanism for this. Maybe actually we have... Well, the question is, should perhaps we be thinking about a better way than 5011 to handle key roles? Because there's 1,000 ways that software gets updated every day on every kind of device that's actually fairly reliable, and this seems to be the most complicated one that anybody's ever seen. So wouldn't it be nice if we actually had something that you could use that was straightforward, that you could measure straight away, and that wasn't subject to all this incredible nonsense that we have to deal with?
I think it's not actually that bad. The one thing that's missing is bootstrapping, right? Otherwise, some of the issues that you see, like with non-writable state directories, you always have. People will just not be able to update the files, and then that's always going to be there no matter what you do. But in itself, I don't think there's anything fundamentally wrong with 5011, except for the bit where bootstrapping isn't there. So, like the whole late installation thing, if you start less than 30 days before the key roll, yeah, tough luck.
Andrew Sullivan, and I'm not speaking for anyone. You said a moment ago that you thought the conclusion here was this is all, it seems to work. But you had several examples of things in there that were little regressions or corner cases that didn't work and so on. The people who write these things are among the smartest people I have ever met. If they can't understand 5011 such that they don't have regressions in it, we're going to have problems in the future because the chances that there will be a regression in the future seem to me to be pretty high. Somebody else is going to be maintaining this code, and somebody else is going to do the same regression that caused some of the regressions that you saw here. And this is code that we're again not going to touch for 5 years. So I think that there's a risk here that is one of the conclusions that we can draw from your excellent results, and I really appreciate you doing them. And that is that this is a very dark and dusty corner that is unlikely to keep clean, and I'm a little bit nervous about this mechanism for that reason instead of the more general complication of 5011.
Yeah, I think, of course, one of the problems with this is that it's only been used every so often, like, every 10 years or so, and nobody tests that. And especially, I think people test sort of the happy path, and then all the... Sorry?
Weekly key rolls.
Exactly, let's do that.
First of all, thank you for your work because you did a great
amount of work and created a couple of seniors. Exactly as you said, we were testing the happy path, right?
Yeah.
So getting back to the point from Andrew, I think that if you could contribute the tests so they are public and we can integrate them to, you know, the usual test suite we run before every release, it will help greatly to avoid regressions, right? So if you can negotiate with the right guys who paid for your work to get it public, please do so.
Yeah, I'm pretty sure they're very open to this, but we'll talk. I will do that. Thank you. All right, anything more? Thank you very much.
So I think we're running a little bit ahead of schedule, so I'm going to see if Ray or Keith want to say anything. So
Just resume at 11:30 schedule.
okay, all right. So we have a break until 11:30. So thank you.